How you would design a MySQL cluster to handle 5 billion MySQL SELECT queries a day. To design a MySQL cluster capable of handling 5 billion SELECT queries per day, you would need to consider several factors, such as the cluster architecture, hardware requirements, database optimization, and high availability. Here's a high-level overview of the design considerations. Cluster architecture. A clustered MySQL setup allows you to distribute the workload across multiple nodes, to improve performance and scalability. One popular option is MySQL Cluster, which provides a distributed, shared nothing architecture. Another option is to use a master-slave replication setup, where multiple slave nodes handle read queries while a master node handles write queries. Hardware requirements. The hardware setup for the cluster should be carefully planned to handle the high query volume. Consider using high-performance servers with ample CPU, memory, and storage capacity. SSD storage can significantly improve query response times. Database optimization. Optimize the database schema, indexes, and queries to ensure efficient data retrieval. Use appropriate indexing strategies to speed up SELECT queries. Regularly analyze the query execution plans and optimize slow queries. MySQL provides various tools for query optimization, such as the explain statement. Load balancing. Implement a load balancer to distribute incoming SELECT queries across the cluster nodes. This ensures that the query workload is evenly distributed, maximizing performance. Consider using a dedicated load balancing solution like HA proxy or a hardware load balancer. Caching. Utilize caching mechanisms to reduce the database load and improve response times. Consider implementing a caching layer like Redis or Memcache to store frequently accessed data. This can help handle repetitive SELECT queries without hitting the database. Horizontal scaling. If the cluster starts to reach its capacity limits, consider adding more nodes to the cluster to handle the increasing load. Horizontal scaling allows you to add more servers to the cluster as the demand grows. High availability and failover. Ensure high availability of the MySQL cluster by setting up failover mechanisms. This can be achieved through technologies like automatic master-slave failover or automatic failover with MySQL cluster. Regularly back up the database to avoid data loss in case of failures. Monitoring and optimization. Implement monitoring tools to track the cluster's performance, including query throughput, response times, and resource utilization. Analyze the collected data to identify performance bottlenecks and optimize the cluster accordingly. Use tools like MySQL Enterprise Monitor or open-source solutions like Prometheus and Grafana. Remember that designing and managing a high-performance cluster is a complex task. It's recommended to involve experienced database administrators and consider professional support services from MySQL experts if your application has such high demands.